Half a day. My name is Maria Jhonnie Villareal, a graduate student and research assistant for the Water and Environmental Research Institute at the University of Guam under the advisement of Dr. John Jensen. And this poster is about the hydrogeological and speleogenetic characterization of a discharging coastal cave, Ayuyu Cave, in Northwest Guam. In this poster presentation, I will show you what we have learned from exploring and mapping this cave. Aquifers in karst environments presents special challenges because they are characterized by complex plumbing composed of three-dimensional networks of fractures and conduits. Among karst aquifers, carbonate island karst aquifers are even more complex because the limestone bedrock retains much of its original porosity, and the fresh groundwater resides in dynamic equilibrium atop the underlying salt water. The Northern Guam Lens Aquifer is a carbonate island karst aquifer from which 40 to 44 million gallons per day of fresh water is withdrawn from between 100 and 120 wells to supply 90% of the drinking water for the island's more than 159,000 residents. The existence of coastal freshwater seeps and springs and submarine groundwater discharge is an inherent feature of the Northern Guam Lens Aquifer. Among the mapped seeps and springs along the northwest coast of Guam, the highest point concentration discharge was observed in Ayuyu Cave, measured to be at least 2.3 million gallons per day. As you can see in the location map, it is also located at the tip of a fault structure, which makes it even more interesting and the geology expected to be complex. In this study, we explored and investigated Ayuyu Cave to understand the discharging phenomenon of the Northern Guam Lens Aquifer. My primary objective for this research is to examine and document the geological features of Ayuyu Cave and the hydrogeological behavior of the groundwater discharge associated to it. To do this, I looked at both the surface and subsurface features in the study area to examine the karst features above and below. For the surface, I used lidar point cloud data processed into a digital elevation model to identify and characterize surface features such as depressions and lineaments. Subsurface study required good old exploration and survey and traveling 30 minutes by boat to get to the study site. Using Discharging, a digital surveying tool specific for cave mapping, and using softwares TopoDroid and Therian, I was able to create accurate maps of Ayuyu Cave. So illustrated in this poster are the plan and profile view maps of Ayuyu Cave, highlighting some cave features that we've mapped and inventoried. The narrow entrance of the cave is at sea level. It opens into the main chamber, which is a big room with high ceiling and big stalagmites that goes up to the ceiling. From the main chamber, it tapers into a narrow and low ceiling passage towards the daw's leg, a tight crawl space that challenges one's flexibility. Moving further along the cave, the low ceiling passage leads to another big room where the presence of brecciated rocks was first recognized. And in this room, ceiling slab breakdowns lay on top of huge toppled or broken stalagmite. And this is called the brecciated room. In two places, we noted the presence of air drafts at Daw's Leg and at the brecciated room, which suggests that the walls are fractured enough to allow for a nice breeze to travel all the way in. There are varieties of speleothems in the cave, draperies, soda straws, massive and composite stalagmites, all indicating that the past and present hydrogeological conditions that is conducive for their formation. The most striking feature we discovered in this cave is a pool, which is essentially the water table, observed to rise and fall with the tide. And the total mapped cave distance is at least 130 meters. Ayuyu Cave exhibits a hybrid morphology. It has a dissolution features archetypical of a flank margin cave, that which forms synchronous with sea level position. At present, most dissolution occurs at the water table where fresh water infiltrating from the surface mixes with salt water. And this mixed water facilitates aggressive and fast dissolution of the limestone bedrock at the freshwater saltwater interface. The water in the cave pool rises and falls with the tide, but is calm, gently flowing, and relatively fresh in contrast to the fast-flowing salty discharge at the entrance, despite being only 55 meters apart. This suggests that the huge volume of water that discharges from the cave is coming from elsewhere. Speleothems in the Ayuyu caves, such as stalactites, stalagmites, soda straws, and draperies, are indicative of a hydrogeological cave system that persisted for a few thousand years, albeit that which belongs to a vadose-phreatic type of dissolution. Fracture and collapse features are present at every corner of the cave as well. The cave features mapped and inventoried reveals the significant influence of faults and fractures on both the hydrogeology and speleogenesis of this discharging coastal cave. Geologic features such as faults can permit or hinder water flow through certain zones, thus forcing water through well-defined paths, as we believe is the case for Ayuyu Cave. This cave research was possible through the generous funding and support of NASA EPSCoR, WERI, and the University of Guam. And that concludes my presentation. Si Diyos Masi.